Okay, so I wanted to make one video on just a couple things of note. The first thing is about isomers. So there's two types of isomers. There's structural isomers and there's stereoisomers. Structural isomers are when you have two compounds that have the same formula, but they have a totally different structure. So we're looking at something like this. You see how butane and 2-methylpropane both are C4H10? So they have the same chemical formula, but they are different. They're not the same compound. This has all of the carbons in a straight line. This one has them. It has a branch in the middle. So they are different. They even have different physical properties, right? They don't have the same melting or boiling points. They'll react differently. Well, once we get going and stuff, you'll see how things react differently. So those are structural isomers. Stereoisomers are when you have a double bond and you have a different arrangement in space around that double bond. So this is the cis and the trans stuff. So we have the trans configuration where the groups are on opposite sides, and the cis configuration where the groups go on the same side. So when you have a double bond, because of the way the 3D shape kind of unfolds here, you're going to have something that can come out on the top and on the bottom of the double bond. Okay, and so you have the chance for the carbon groups to end up on the same side, both on top, or on opposite sides, one on top, one on bottom. And so we have to differentiate between those configurations. This is what they would look like in the three-dimensional type of ball and stick model. You have trans, they'll be on the opposite sides, and cis, they'll end up kind of on the same side. So keep that in mind when you are thinking of isomers. There's two different types, structural and stereo. The other thing of note that I wanted to talk about is an asymmetric carbon. So in some of the practice we're getting ready to do, it's going to ask you to identify the asymmetric carbon. What that means is it's a carbon that is bonded to 4 different groups. Now, that does not mean it's bonded to 4 different atoms. It means it's bonded to 4 different groups. So if you're looking at these carbons here, you'll have to notice that a lot of these are, they are all bonded to 4 different things. Okay, so like this carbon, it's 3 hydrogens, 1 carbon, so on and so forth. But if you're looking at the groups that something's bonded to, you see how this carbon right here is bonded to 3 methyl groups, and then the other group is this thing over here. That would all be considered a group, so 3 methyl groups in this. But since it's got 3 methyl groups, 3 of them are the same group. This carbon right here, however, is actually bonded to 4 different groups. It's bonded on top to that hydrogen, bonded on bottom to the bromine, bonded to the right by this whole thing over here, and bonded on the left by the methyl group. Those 4 groups are different. Yes, I know that the carbon is bonded to a carbon here and a carbon here. So yeah, it's 2 of the same atom, but they are different groups because of how they are attached to other things. So that carbon would be the asymmetric carbon right here. So that's what it's talking about when it asks you to identify if something has an asymmetric carbon, or to circle the asymmetric carbon, or whatever. Hopefully that's helpful to you. I just thought those would be